we're going to have two different ways to measure slope. Today is day one. It works best if you have a picture. All right, so today works best when you're given a picture of a line. Fantastic. So, the definition of slope. The definition of slope is how steep something is. Okay, so if something is really steep, like a big hill, it goes down really fast, we would say that has a really big slope, a high number for a slope. If something is pretty flat, right, like this ground right here, we would say that it doesn't have much steepness at all, right? It's basically perfectly flat, so it would have a very low slope, probably close to zero. Right? That's how low it would be. That's the definition of slope. It says it right there. Slope is steepness. Fantastic. The first formula we use to calculate slope is called rise over run. We heard that before? Yeah, grade 9, you should have learned that. In science, I think they do that one too, right? So if you took science 10, hopefully that rings a bell. I do rise over run a little different than some people. So this book talks about two different ways to count it. They say the rise is positive if you go up, negative if you go down. I agree with that, all right? So I always do that one. And then they say the run is positive if you go right, negative if you go left. I never go left. All right, so when I calculate slope, I always go to the right, no matter what. And I know my run is always going to be positive. And all I have to worry about is if I went up or down. Does that make sense? So you never actually need to know that negative is to the left. I mean, it makes sense. You're going left, that would be negative, right? It's kind of backwards on your scale. But for us, we just ignore that altogether, and we just don't do it. We just always go to the right, so our run will always be a positive number. Our rise is positive if we move to the right and go up. Our rise is negative if we move to the right and go down. You'll see what I mean in a second, and it'll kind of help. So we've got three lines here. We're going to calculate the slope of all these lines. We're going to fill out this little chart. And we're going to start with line AB. Looking at that, line AB is from here to here. When I calculate slope, I find 2 points on the line that perfectly intersect on the Cartesian plane, meaning it's like right at the center of one of the grid points. Like right here, A is right on the grid. See how it's perfect? And then you can pick any other point you want that's perfectly on the grid. This would not be, but this would be. See how it intersects perfectly? So I picked those 2 points. Once I've picked 2 points on the line, I start on the left one every single time. And then I count how many to the right I have to go. In our case, I have to go to the right 1, 2, 3. That represents our run. And our run is our movement to the right. So run 3. Then I count how many up I have to go. In this case, 1 up. That's our rise. Because we went up, it's a positive. If it had been down, it would have been a negative. Your slope is rise divided by run, 1 divided by 3. Now, sometimes you're like, well, what if I want to go up first? So, if you did it this way, starting at A, you go up 1 over 3. 1, 2, 3. You would still have a rise over run of 1 divided by 3. It's the exact same. So it doesn't matter whether you choose to calculate the rise first or the run first. As long as you're going from one point to the other, left to right, you should always be good. Awesome. Let's try line CD. So if we look at C to D, I'm going to pick 2 points that are on that line. Right here is 1 point. Another point would be right here. It looks close in a few spots, but I think that's the only spot where it's perfect. To calculate slope with a picture, we work from the left point to the right point. I like to go to the right first. So for us, I would have to go to the right 1, 2, 3. That's my run. My rise is then how many I have to go up to get to the point. To get to that point, I have to go 1, 2, 3, 4. That means my rise is 4. You want to calculate the slope, rise divided by run, 4 divided by 3. Perfect. Try the last one. E to F. You can do it on your own. I actually don't think I like the point that I picked, though. You probably see better in your book. It doesn't cross perfectly there, hey? Crosses better up here. Yeah, like edge to edge, yeah. Once I looked at it, I was kind of like, I don't like that. Alright. So, if you want to calculate the rise of run over this, I screwed up the first time I did it. Hopefully you were watching me, and then I did it backwards order than normal, and I almost confused myself. So it was perfect if you're watching me, if I confused you really well. I looked at my line, I picked my 2 points. I think the only 2 points it crosses perfect are right on the ends. This one's a little ambiguous. It's hard to tell if it crosses right there or not. I don't think so. I think it's a little bit off, but it's hard to tell. So if you ever have a question on a test, it's usually very clear, or they'll actually label the points for you. So if they ever put like dots on the line, those are the points you should use. Okay. Once I chose my 2 points, I want to start from the left point and go to the right point. In this case, I had to go down in order to get from my left point to my right point. Because I went down, it's a negative rise. But because I'm still going left to right, it's a positive run. Make sense? Go from the left point to the right point. If I have to go down, it's negative, right, positive. Awesome. Once I got my rise over run, it's negative 5 over 3. And that would be my final calculation. That's slope. So rise over run works best with pictures, in my opinion. We'll look at a couple of these. We won't do a lot of them. We'll do A to B, and then we'll do A to C. Yeah, let's do that. So, looking at this line, you want to calculate the slope from A to B. They've already kind of marked it out for you. So from A to B, it would be 1, 2, 3, 1, 2, 1, 2, 1, 2, 3, 1, 2. Rise would be 2, run would be 3, slope would be 2 over 3. If you want to go from A to C, so you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's a big run of 12. If you were rising, you go 1, 2, 3, 4, 5, 6, 7, 8. Rise 8. Let's put that in. 8 over 12. Okay, looking at those 2 slopes. Those 2 slopes definitely look different. Yeah, we have 2 over 3, and we have 8 over 12. 2 different fractions, very different fractions. If we look at our line over here, and we talk about the lines that we just measured. So we measured the slope from A to B, which is right here. A to B. And then we look at the line from A to C, it's right here. And we agreed earlier that slope is the steepness of something. Agreed? is line A to C any steeper than A to B? No, like logically looking at it, it's the exact same steepness. These are on the exact same pathway. But their slopes look incredibly different. The reason why is because one of those fractions could be simplified. So remember that 8 over 12, you could actually reduce that fraction. Your calculator will do it for you. A lot of us didn't have these calculators in Unit 1, but now it's going to be a very handy thing for you. So to be able to convert to a fraction with these calculators, a reduced fraction, you would go 8 divided by 12 and hit enter. When you hit 8 divided by 12 and then enter, you get a big decimal, right? 0.66666. Then hit math. The button's right here on the side. Option 1 is frac. That means convert it to a fraction. Hit enter on that. And hit enter one more time. And it'll tell you that your reduced fraction is 2 over 3. There's going to be a lot of times where maybe your answer is a little bit off from the actual answer, and that's because it needs to be reduced. All right? Make sure you're reducing fractions whenever possible. Worst case scenario, if you converted both of these to decimals, they're both the exact same thing. They're both 0.6 repeated. And that's another way you can test the slope. 0.6, 0.6, 6. Fantastic. Just looking at this picture, that means slope A to D would still be the same, right? A to D is still on the same line, and that means slope B to C would still be the same because it's on the same line. So they would all have the exact same slope values because they're all the same steepness. Awesome. There's two special cases of slope, right? And they're kind of tricky to calculate. I'll explain it the way I think it makes sense, and then I'll show you the math behind what makes it make sense. Okay? Those two special cases are horizontal lines and vertical lines. Lines that are perfectly flat and lines that are straight up and down. If we look at lines that are perfectly flat and we try to calculate the slope of those things, and if I just remember that slope is steepness, would a perfectly flat thing have any steepness? No, there's no steepness there. And what's the best way do you think to represent no steepness? 0, right? Horizontal lines always have a slope of 0. Because they're not steep at all, right? They're perfectly flat. The reasoning behind why it's 0 has to do with what the rise over run would be. If you looked at a picture, let's look at A to B. And I said, calculate the rise over run. And you pick 2 points. You're like, okay, here's a point, here's a point. The run would be 1, 2, 3. What would the rise be? 0. You'd have 0 divided by 3. 0 divided by anything equals 0. And that's why horizontal lines have slopes of 0. Because their rise is 0. And 0 divided by anything doesn't exist. Awesome. You guys usually do pretty good with horizontal lines. The vertical lines are a little more tricky. Okay, so if you were trying to talk about the slope of a vertical line, that's like being on the edge of a cliff that goes straight down. And if you were to ask yourself, like, how steep is this hill? It's not a hill anymore, it's a cliff, right? And if you're like, how steep is that? It'd be hard to describe how steep it is. Because it's straight down. It's off the edge of a cliff. We call vertical slopes or vertical steepness undefined. I think we call it undefined because it's impossible to describe something that's that steep. It's straight down. It's like infinity steepness, right? You can't even describe it. That's why I call it undefined, logically. Mathematically speaking, the reason it's undefined is because of the run. So if you look at this guy, and you take 2 points on any part, let's go right here and right here. And I say do rise divided by run. The rise would be 1, 2, 3. divided by the run, did you have to go left or right? So divided by 0. If you try to divide by 0 in your calculator, what happens? You get an error, right? It's not possible. You can't divide something by 0. You can't take 3 things and break it into 0 groups. Doesn't make sense. This is mathematically not allowed. We describe it as undefined. You definitely will get some questions on that kind of stuff. It's kind of almost like a random fact, right? That's just something you need to remember. There's the story behind it and the logic behind it. Either one works as long as you know horizontal is 0, vertical is undefined. Awesome. You can fill out these statements if you want. Horizontal lines have a slope of 0. Vertical line segments have an undefined slope. Yeah, for sure. Fantastic. We're going to look at some of these slopes right here. And we're going to calculate all the slopes for all 6 of these lines. Actually, I'll let you do it. So there's a chart right below. Try to fill them out for all 6 lines. Do your absolute best. Let's look at these. I had to zoom out a little bit so that I could fit it all on my screen at once. I've calculated the slopes there. I've shown my rise over run for each one of them. Hopefully yours match up somewhat the same. The reason we want to do this activity is just to look at a trend. All right, if you look at the red ones, what do we notice about all their slopes? They're all positive. If you look at the yellow slopes, they're all negative. Visually, these 3 lines all look the same in the sense that when you go from left to right, they're trending upwards. See how they're all going towards the top right corner? If you look at yellow lines and move from left to right on any of those lines, they're all trending downwards overall. You should be able to look at a line and know if the steepness is going to be positive or negative just by the direction that the line is going. From left to right, if it's going up, it's going to be positive. From left to right, if it's trending down, they will all be negative. So even if you forget, you're like, oh, is it up, down, positive, left, right, positive? I don't remember. You should be able to just look at it and know, okay, my slope has to be positive when I calculate it because it's going up. This one's trending down. Awesome. We're going to skip past the couple questions on the assignment, and we're going to look at some word type problems just to make this stuff a little bit trickier, a little bit harder, a little less just calculated slope. This question, it's okay. It's okay. I'm okay with it. I don't love it. It's hard to read the picture, in my opinion. I think the meaning behind it was nice, but the picture's hard to read, and the understanding's a little tricky. Okay, so this says a grid has been superimposed on the sketch. So if you look at this picture of a guy building a house, you can tell there's a grid on there. It just gets really grainy in the middle, which is why I don't really like it. But there is a grid there. Okay, it's a Cartesian plane. A, estimate the pitch or the slope. Pitch is just another word for slope. Of the roof to the right of the worker's head. Okay, so looking at this, I think what they want is they want you to estimate the slope of this part of the roof. Because that would be the slope of the roof, right? Like that line right there. You could also do along here if you wanted. But you notice those are the exact same steepness, just 2 different spots of the roof. One's the bottom of the roof, one's the top of the roof. I think their intention was to do the bottom because that line is bolded for you, which is kind of what makes me means that's the line they want you to calculate. That makes sense? So they want you to figure out the slope of the roof, the steepness of the roof. Looking at that line, if I want to figure out the steepness of the roof, I need to pick 2 points on that line that perfectly cross my grid. Let's go right here. There's one. I like that point. It looks like we cross it. And then let's go. Hard to tell right there. It looks like right here passes perfectly. You can see better than I can probably. Right there, cross perfectly on your page. Yeah, perfect. There you go, right there. Once you've picked 2 points that you feel perfectly cross the grid, I know this one's hard to tell. I understand that. Then we would calculate rise over run from left to right. Before we even do that, is our slope going to be positive or negative? Positive, because it's trending upwards, right? So as we do our rise over run, our rise is 1, our run is 1, 2, 3, 4, our rise is 1. Our estimated pitch of the roof, or slope of the roof, is 1 over 4. That's the same thing as saying 0.25. And if you want to do a decimal slope. We don't really do decimals, but just in case you're wondering. It says, could the grid be used to estimate the pitch of the roof the worker is standing on? So if you look, he's standing on this roof right here. If you're trying to figure out the pitch of that roof, I would be looking at the edge over here. And see if we could estimate that. You don't have to. You just have to logically think, could you? Could you calculate that slope? I think so. I think because it's the edge of the roof that you could do it. If you could only see this flat part, then it's a little trickier. But because we can see that edge, I would say yes. You could calculate that slope of the roof because you can see the edge line of it. Awesome. Part A is really the only part I wanted to do with you. Question 3. Drawing lines. So, this is giving you slope, then drawing the picture. Before was giving you the picture, then finding the slope, right? So we're going to go backwards now. We're going to try to draw a line that has a slope. This question says, draw a line segment on a grid which passes through the point -4, 2 and has a slope of -2 over 3. The line segment must be long across both the x and the y axis. That means just make the line nice and long. Write the coordinates of 3 other points on the line segment which have integer coordinates. Don't worry about the word integer. That just means whole number, right? So you can't be like 1.5. It has to be this. All right, how to tackle a question like this. When they ask you to draw a line segment, they should always give you a starting point. The starting point is the point it passes through. That means the starting point. So for us, it's at -4, 2. -4, 4 to left, 1, 2, 3, 4, 2 up, 1, 2. That's our starting point. Perfect. After you have a starting point, they should give you a way to find other points. I like to call it like a map to the other points on the grid. Our map is the slope. They said slope is -2 over 3. That is your guide to the next point. The reason it's your guide is they're saying the next point has a rise of -2 away and a run of 3 away. That makes sense, right? So if I went from that point and I went down 2 and over 3, that would be the next point on my line. So down 2, 1, 2, over 3, 1, 2, 3. And that's going to be the next point on my line. I could keep doing that to find more points. down 2 over 3. Down 2, 1, 2 over 3. 1, 2, 3. And that's my next point. I technically could also work backwards. So instead of saying down 2 and to the right 3, I could go backwards. And I could go left 3, 1, 2, 3, and up 2. 1, 2. And that would be another point on the. Does anybody have any questions about finding those other points? They give you a starting point, they give you a map. The map is rise over run, and it guides you to the next spot. They said write 3 other points. My 3 other points are those 3 purple points. Let's write out their coordinates. The first one was at x value -1, y value 0. That was this guy. This one was x value 2, y value -2. And this one up here was -7, +4. It really was connecting my lines on that one. It also said to draw a line connecting these guys, so let's do that. Go ahead and draw a line connecting them. Just put a flat surface across the center of all your dots. You should get something like that. That's not that bad. It's kind of straight, curved a little bit. Fantastic. This is another type of question you're almost guaranteed to get. Right? They love to give those types of questions. So that's giving a slope, creating a line. All right, I think that's our last question. A line segment has a slope of -5 over 7 and a rise of 12. Calculate the run as an exact value. All right. They've given you a slope. We know that slope equals rise over run. That's our starting point. I'm just going to move that negative. They had those. We should do those right there. Everyone's happy with that? Fantastic. The second part of the sentence, they say, it has a rise of 12. Calculate the run. Looking at this, they said rise was 5. But remember how we could have different fractions, right? Similar fractions, like fractions. That's what they're describing right now. They're describing another fraction with a rise of 12. So they're saying you should have this slope, but instead of rise, it should be 12. Figure out what the run is. The run would be x. So what value of x would make these two slopes the exact same? This is the hardest part, I think, of the slope stuff. Is taking a slope, trying to find a similar fraction based off of only one number. In our case, the rise. All right, the best way to do this is to take your two fractions and make them equal to each other. So that's what we're going to do. We're going to say 5 over 7, and we're going to say -7 equals 12 over x. The negative can go with the 5 or the 7, it doesn't matter. Your goal is to get x by itself. When you get x by itself, it has to be on the top of a fraction. Okay, so right now it's on the bottom of a fraction, which isn't good for us. So we need to get it to the top of a fraction. To get it to the top of a fraction, you multiply it to the other side. So you're going to multiply both sides by x. When you do that, it'll cancel out on the right side, and now you will have x times 5 over negative 7 equals 12. Awesome. We got x by itself, like off the bottom, but now we have it multiplied by a fraction. How do you get rid of something that's multiplied? You divide it, but you're going to be dividing a fraction, so it's going to be a little awkward to put in your calculator. But our goal is going to be to divide this to the other side. So we divide by 5 over negative 7. Divide by 5 over negative 7. On this side, it'll cancel out. On the other side, you'll be left with this. X. I don't want it to look like that. X equals 12 divided by, and that 5 over 7, I'm going to put it in brackets. And when I put it in my calculator, it's 5 over negative 7. My calculator is also going to need those brackets. The brackets tell your calculator this is a fraction. Like the 5 over 7 is a fraction together. If you don't put the brackets, your calculator will go 12 divided by 5 and then divided by 7. That's not what you want. You want 12 divided by 5 over 7. That's a fraction. If you put that in your calculator, so 12 divided by 5 divided by negative 7, but with the brackets around it, what do you get as your run? Negative 16.8. Negative 16.8. And that's exactly 0.8, right? Yep. That's your run. So if you had a rise of 12, your run would be negative 16.8. And that would give you the slope of negative 5 over 7. Those are equivalent fractions. They're just awkward because one of them is a decimal value.
Could you not just cross multiply?
You definitely could. So if you look at that and you know how to cross multiply and then divide the other ones over, that would work too. Yeah. I've tried that in the past and it usually loses more people than it helps. So I'm trying something different, see if it helps out. Alright, so I cross, what she's saying, you might remember in grade 8 you probably learned cross multiply, maybe grade 7. But you would cross multiply the x and then divide the 5 over negative 7. Cross multiply divide. Awesome. Again, that's one of the harder questions you see, especially once they throw in like a little bit of word problems to it. And they say like, oh, somebody has, they want to get a slope of 5 over 7, and they have to have a rise of 12. What would their run be to be able to build this ramp or something like that? And they'll do something weird like that. Awesome. When we come back from the weekend, we're going to do slope again, but a different type of calculation of slope. I think you're going to want to master today's slope